In this lesson we're going to look at the relative formula mass. Now the symbol for the relative formula mass is this, m and the little r down there. And what does it tell us? Well, first of all it tells us the relative mass of a molecule or compound as opposed to the relative mass of an atom, which is called the relative atomic mass. So how do we determine this relative formula mass of a molecule or compound? Well, to do this we need to find the sum of the relative atomic masses present in that compound or molecule. And to do that we need to look at the periodic table. So let's take a snippet of the periodic table here. And you'll recognize that on each element there are normally two numbers given on the periodic table. The top number is the atomic number, which is given the symbol Z. That's the number of protons that are present in the nucleus of the atom. And the bottom number is AR, that's the relative atomic mass of the element. So once we know this from the periodic table, we can then determine the relative formula mass of any molecule or compound. Let's have a look at some simple examples. Okay, suppose I want to find the relative formula mass for sodium oxide and, say, nitrogen. Well, the first thing we've got to do is determine the formula always. So for sodium oxide, this is Na2O. And then we look to the periodic table to determine the relative atomic masses of each element. So in the case of sodium, you'll notice here that it's 22.99. Well, we'll round that off to 23. And we have two sodium atoms present in the compound. So that will be 2 times 23 plus 16 for oxygen, which will be equal to 62. Okay, so the relative formula mass for sodium oxide is 62, and for the nitrogen molecule, well, if you look on the periodic table, the relative atomic mass for nitrogen is 14, and nitrogen, as it occurs in the air, is a diatomic molecule, so we put a 2 here, so that means its relative formula mass will be 2 times 14, which will be equal to 28. Now, I would like you to pay attention to both of these numbers here. You'll notice that I haven't put a unit here. I haven't put the unit grams here, because although we're talking about the relative formula mass, this isn't strictly speaking a mass, it's just a relative number. Now, when we talk about the mole later on, you will see how we use this number or these numbers to physically calculate the masses of substances in grams. They are very, very important for doing that. But these aren't actually masses in the conventional sense of the word. They are just numbers which indicate the relative masses of the molecule or compound. I'm just going to try and explain that statement a little bit further. Let's take, for example, water. Okay, and the water molecule is H2O. So the relative formula mass for water will be 2 times 1 for hydrogen plus 16 for oxygen, which is equal to 18. Now, again, that isn't really a mass, but what we can say is this, that if we take a mole of water molecules, and a mole, you'll learn about that in the next lesson. Okay, this is just a very, very big number, and it's equal to, in fact, approximately 6 times 10 to the 23. That's a huge number. But if we take a mole of water molecules, okay, then they will weigh exactly 18 grams. Okay, you can physically take that mole of water molecules, put it in a beaker, and you'll find out that it will weigh 18 grams, and that is where this is linked to the relative formula mass. Okay, so it all kind of fits together, ties in when we start to use the mole.